So my session today is going to highlight the way in which we can utilize AI for this particular use case, having to deal with attribute mapping and enrichment. So before we get into how we can actually go about leveraging AI, let's take a step back and consider this common concept of master data. So when we typically think of master data within an organization, we may typically think of dimensional tables and members and how they're really maintained within an organization's ERP, so your SAPs and your Oracles. Increasingly, though, there are really more and more instances where we want to be able to enrich or enhance that data to really improve the way in which an organization may want to look at their business. But why is it so important for us to get this right, and why is it actually so hard to go about doing it? So firstly, master data, when properly maintained and evolved, is going to provide that single source of truth that can be used across an organization. So a data product that's, say, accessing the same master data information as another product should always roll up and aggregate to the same top-level figure. And having this in that central location, accessible to all areas of the business with that clear, common definition, ultimately is going to lead to less confusion and lead to some streamlined decision-making. It can also bring together many different sources and provide rich perspectives for different types of analyses. So, for example, if a new data source is collected from a new external data provider, there's a new flag or there's a new attribute I want to define, we can and we should be able to bring that in cohesively alongside our other existing internal data to help inform those further analyses. And lastly, our master data will evolve with our business as well as within the environment in which that we're competing into. So really, despite the importance within an organization here, it really doesn't come without its challenges. And the first of which is one of lacking governance and ownership. So maintaining master data really requires the buy-in and alignment from many different teams, many different business functions, and different stakeholders too. So it's really hard to ensure that everyone is going to be happy with the way in which we're really defining these fundamental components of what is essentially the lowest level of granularity in how we're running our business. But even harder to really define who should be responsible for owning this data asset. And because of all the teams that are involved with this process of maintenance, it tends to be incredibly complicated. So it could follow a lot of legacy transformations that are really accumulated over the years, and it makes it really hard to trace back what those transformations can be due to a variety of different factors. And again, that's going to compound further and further as we look to make our master data richer with more logic and more sources. And because of all this, frankly, it's just really hard to keep up with the pace in which that we need to, right? But what we can do is use AI as a tool to remedy these challenges and provide a significant benefit, really, to how we can go about the management and overall evolution of a very critical data asset. And up next, what I'm going to do is just dive into a couple use cases and how we can do just that. So first, going to touch on the data mapping challenge and kind of a layered approach to how we can go about solving it before I'll just jump into a demo to illustrate it a bit further. So again, just a forewarning before we get a little too deep, it's going to be, our examples here will be based on the persona of working at a consumer goods company, typically something pretty relatable. At the end of the day, we really are all consumers, right? But certainly the concepts and the approaches that we're discussing here are going to be applicable to really any industry. So our first use case to address is one of the biggest and most valuable, but one of the most, the least appreciated tasks in developing data and AI solutions. And that's the mapping and the alignment of different data sets from different sources to common business hierarchies. So there are obviously many reasons why an organization may want to do this, but an example would be, again, coming from the consumer goods angle, is if we were about to embark on a collaborative trade analysis with our retailer partners, so like a Walmart or a Tesco's. And on the one hand, it's really important that we as an organization can view our products using our own nomenclature, our own definitions. But when working with our customer, it's just as important to be able to provide that external lens that a retailer like Walmart or Tesco's, so they're familiar with what we're doing. We can have that conversation, the like-for-like analysis, the apples to apples, right? So the alignment across hierarchies is very important. But traditionally, this is something that's been carried out using mapping files or manual solutions that require analysts to assess that new master data that's coming in and really determine the most appropriate member to map to within your common hierarchy. And for historical data, really mapping this can be a monumental effort. And further to that, right, keeping on top of it on an ongoing basis across all the data sources that we may be ingesting can really consume a lot of valuable time and ultimately delay the value to our business and our business teams. And to just complicate things a little bit further, like Sanjay mentioned, everything is data. And we're seeing richer new data sources emerging, including some unstructured ones that we're ultimately also going to want to look to map and align to our data for even greater insight. And ultimately, what we can do is use AI to help us with this. So the case we're going to be looking at deals with this idea of the proliferation of the amount of data organizations are consuming these days. And the amount of data sources, like we're talking about, really means disparate hierarchies, disparate codes, and ultimately different perspectives that really need to be aligned to this common enterprise view of the world. And we can use AI to really help us perform this mapping to obtain that common perspective across all of our external data to our central core hierarchies. So in our example, we have our corporate hierarchy that we're looking to get to, but many other external data sets coming from our retailer partners that I talked about previously. So listing a few here, but list is obviously much more expansive than this, and it doesn't include other external data sets, syndicated, panel, or some of those unstructured ones that I referred to previously. And while we can programmatically determine some of these matches, which I'll get to quickly on the next slide, there are going to be instances where identifiers and codes are really different across these different data providers, and the data might need to be mapped at different granularity levels too, so it's another layer of complexity. So this is ultimately a very laborious process, and one that becomes really even harder to maintain, particularly as we're looking to identify new innovation products, some evolving segmentation, one of which we'll get to a bit later as well when we talk about enriching our data. So I mentioned that we can use AI and large language models to help perform this mapping, but it's not the only approach, right? And really should be used to help benefit an existing mapping process, and not just for the sake of using AI. So how do we go about doing this? So we'll want to start with exact matches using simple joins across our data sets. So we can think there could be some small data cleaning operations that we could undergo to facilitate some more of those matches. But ultimately, this is our safest, it's our most tried and true and way about we can go about mapping different data sources together with one another. And we can then move on to something maybe a little bit more complex, a little more algorithmic with similarity matching. So we can use something called Levenshtein's distance as an example here. It's just an algorithm that you can use to calculate the similarity of two phrases to one another. So for example, if I had a product description that said something like Brendan shampoo versus Brandon shampoo, we could reasonably apply some sort of similarity matching that could calculate within that certain level of confidence that those products are or could be the same in spite of what I would think is a spelling error. But after that, we have exhausted our first two levels. We can then move to our third, and that is using large language models. So effectively, what we'll look to do in the demonstration later is to ask the large language model to perform this assignment for us based off the appropriate product information that we are passing to it, so that we can determine what that most likely mapping to our internal hierarchy is. And as we can see, as we're moving down this inverted pyramid here, the sophistication of our approaches is increasing. But we're also reducing the number of mappings that we need to do as well. Ultimately, until we can exhaust everything, all of our products, and get to 100% of everything required. So again, just to hammer this point, level 1 approach, we can say we can get to 60% of all of our mappings, followed by the 25% at level 2, so on and so forth, until eventually we have everything that we need to map. But something to keep in mind is that these percentages are going to fluctuate. So I may be more inclined to consider the complexity of my use case, my model, overall computation costs, and overall effort, honestly, when considering how many mappings I may look to achieve at the various levels. So in the very near future, for example, there could be a world where I do away with level 2 altogether and just replace it with level 3, right? So that's certainly a reasonable approach. But really, what shouldn't be lost in showing this diagram here is that AI is being used to improve an existing process and not replace something that we know works very simply and effectively. And just one last point. It's just something to keep in mind with as well, is we may want to have, or we should incorporate some sort of override mechanism for our users to really ensure that there's proper mapping and we're having the proper confidence instilled within our users that this is still working and working effectively when going about performing this exercise. So just to orient everyone before I jump into my web browser here, I'm going to be headed into Databricks and leveraging different components based in Azure. I'm also going to be using GPT 4.1 as my model of choice. So just showing these technologies here for reference, which is what I used. But if we wanted, we could certainly use other technologies to perform those identical tasks. So let's get into it. Right, so here we are in Databricks. Just going to focus on that third level of that inverted pyramid that I just spoke to. First two methods are generally pretty well understood, relatively straightforward. And if we look past the initialization script here, I'll just scroll down a bit further. I'll just run this one real quick. What we essentially are going to be doing is just orient, again, everyone here to the product information that we currently have available within our organization here. So really, what I'm essentially going to be doing, again, is just asking the large language model to describe the product data that we have stored within our search index. So this will just take a second to run. And we'll just see that return very shortly with all the information for my specific consumer goods manufacturer that I'm working with here. So we get a brief information on what we're dealing with here. So we have our product categories, we have hygiene and personal care, inclusive of some additional subcategories as well. But we also get a quick example of some of the products that we're dealing with too that sort of span skincare, hair care, bath and shower, subcategories, categories, diving into more variants and some additional information, observations, calling out that there is a unique identifier that we're eventually going to be mapping to, but ultimately something that we'll get to in a moment, right? So that's what our data is looking like. That's what we're looking to map to within our internal hierarchy. Now, again, the point of this, right, is we're about to be collecting a bunch of external information that we're looking to map to our internal dimensions here. And just for illustration purposes, I've just pasted in a few sample SKU codes. Of course, when we're thinking about productionized AI systems, this would be done in a bit of a different way. So just illustrating what we'd actually look to do in passing these external products to our internal data set. So we can see I have a SKU code here, for example, and what I'm going to be doing in passing to the language model is passing this whole row into it, right? And essentially asking it to perform this mapping for me. I can't really get to a match very easily within what I have. What I'm going to be looking to do is, again, ask that large language model to take the information, so the material description, the category, the subcategory, and asking it to map to our internal code, which is called our product SK or our product surrogate key. So what I'm going to do here is just run this and very quickly. There's only a handful of products here, but the point should still remain, is that we're eventually going to get a result here that is going to map those external codes to the internal ones, nearly instantaneously, right? So we can see the information that I passed to here, and then I'll just scroll down a bit further. And then we can see that the model has succeeded in actually performing that exercise here, right? So it's taken the information that I've passed to it across the material description, across the category, across the subcategory, and it's taken the external SKU code, right, the one that we couldn't map before using our traditional means, and mapping it to something that it thinks best matches what I've passed to it, right? So we have the information passed to it here. We can see just a couple other examples as well. So I know, relatively quick demo, but just to kind of summarize, like what are we doing and what had happened here. I stored my internal data set within that index so that it's accessible by the large language model, and then prompted it to perform that task of mapping that has traditionally been something very manually intensive and certainly one that I can speak from experience with. And that mapping process may not be perfect, right? But it's certainly helpful in providing that first pass in mapping in seconds what could take an analyst hours or days, and really, and helping us with this process. So that's that first example. What I'm going to get to next is another interesting one in enriching our data. So what I'm going to be showing next is how we can take rich textual information like product descriptions scraped from websites like Amazon or from Tesco's like we're seeing here, and apply large language models to produce that new and novel attribution that can really offer some unique perspectives on your business and provide with you a competitive advantage. So previously, the views that we've had on our data relied on internal attribution that's been defined by different analysts across different teams or by the external data providers that are sharing this with us. And internally, that attribution configuration is also, really manually intensive to set up, to maintain, and like we just spoke about previously, align across different data sets and also different stakeholders. Externally too, data providers can be slow to adapt to our changing external environment, which can limit our ability to really see what's going on across business segments that we may want to dive into a bit further. So previously, to keep up with this dynamic, fast-paced business environment, building in that necessary attribution across your portfolio that you may be interested in could really be an insurmountable task. But by leveraging advancements in AI, we can take that text-rich data or that unstructured data to derive attribution that offers perspectives that are really unique to you and to your business, will give you that competitive advantage and ensure that you can keep up with those fast evolving segments like natural or non-naturals, which I'll get to in a moment. So again, here we can see product listing on the Tesco website. Again, as a consumer goods manufacturer, I may have a hypothesis that I want to test, right? And there are certain segments that are driving growth, and I may be unable to quantify it from the available data that I have within my master data, right, in my product dimension. And one of those segments that I may have a hypothesis on would be the natural or the non-naturals one. So I can expect that from a product description that I should be able to determine how to classify these particular descriptions to help drive this analysis. So zoomed in a little bit, but just taking a view of the pure description on the right, we can get a hint, right, as to where this may fall. So highlighted a couple of things that may help us lean to the side of naturals, right? So I can see oats as the first ingredient. I can see apple cider vinegar. I can see free from sulfates. And again, as I, as a person, as a human, am reading this, I will tend to lean to the side of this being a naturals product, right? So the challenge, though, right, is when we may have thousands of products with their own disparate descriptions, it's going to take an incredible amount of manpower to even begin to get to a point where we feel comfortable and where we can test this hypothesis that I may have. And consider that too, right? This is just one emerging segment that we want to test with. Consider this for, other emerging segments too in your product range, and not to mention to see what your competitors are doing as well. So it's really quite challenging and nearly impossible to keep up with this and actually respond quickly. So obviously this is just a single example with a product description from a website, but there are going to be other ways that we may want to get attribution as well. So example would be unstructured documents like PDFs. Perhaps there's some consumer survey information that we may want to layer in and map our products to. Just another example is how we can use AI in ways in which we couldn't before. So what I'm going to do next is head back into Databricks and just show how quickly enhancing this attribution can actually be done. Similarly, I'll run the setup notebook here. And what I'm going to do just to get started is to just write, define or just perform the same exercise that we just kind of did as a group here, but within Databricks here. So this is the same product description that I just had within the presentation. We can see some of the same characteristics. I see apple cider vinegar. Oats is here somewhere, and oh, here it is. Oats is here, and free from sulfates and other information as well. And what I'm essentially prompting the language model to do with just this single product description is to define it, and whether it be a natural or a non-naturals product. So this is the segment that I really want to dig into. So won't dive in too deep to the code itself here, but this is essentially what I'm doing here when I just run this cell. And we'll do, so you can see it just takes a second to run, right? So we're going to print out the response, and we'll see that the large language model has come to the same deduction that I did, right? It's also considering this product to be a natural, right? So what took took seconds for this to occur. But again, the point being that if I want to be able to do this for tens of thousands of my own products, potentially hundreds of thousands when we incorporate our competitors, we want to be able to do this in a dynamic way where we're not just going to be passing a single string of our product description and have that work continuously. We want to do this dynamically with strong data engineering practices, as Sanjay had referenced previously. So that's what this code is going to be doing here. So all I'm going to do is it's a little longer of a cell. I'm just going to run this, but it's going to be running the same exact operation in which I added to, and it's going to be returning that same function into the form of a data frame or our final product table. And that's it. That took seconds to do. But really what I'm going to do next is just display it so that we can all see the products and how that's actually worked. And what we're going to see here is just a few columns. We have an identifier here that we can use to join back to our internal hierarchy. We have our product description, so that's what we're passing to the language model for it to interpret and provide an answer. And then we also have our label, right, whether it's natural or non-natural. So I can see that this is now complete, and we can see that the large language model has done just that, right? So I'm just going to run this cell because this will take a second too. So I'm prepared for that. But we can see the large language model has done that, just as we would expect it to for these slew of products, for this one segment that we want to dive into really quickly. And just taking a look at another example, number ID 8 here, maybe the large language model is seeing this descriptor of honey, and it's thinking, oh, honey's pretty natural, right? So we'll define that as naturals. But that's really easy to maybe see it applied to our product data set here, but where the true value is going to come in is how quickly we're able to then take what we have within our product dimension and combine it quickly for an analysis. So that's what I just want to demonstrate very quickly here within this visualization is, the way in which we're able to tell over the past week that, for example, our natural segment is booming for whatever reason, and non-naturals is decreasing, right? And again, a simple visualization to illustrate sales over time and just illustrate it very quickly with some sample data within Databricks. But it's very easy for us to now take this attribution that we've defined and appended and extended our product attribution table for, and subsequently apply it within our enterprise visualization tool of choice, whether that be Power BI, Tableau, Click, or something else, right? So very easy to take what we have, append our product dimension, and see it materialize very quickly so we can have actionable decisions based off of it. All right, so just have one more point here before getting to the conclusion, and that's just the idea of this human confirmation and human in the loop. So whether you've experienced it yourself or you've seen it in the news, it's possible that Gen AI isn't always going to get the answer right. And this instance, of course, is something that's no different. So one of the ways in which we've seen success in mitigating this issue, right, is by being that tool in the toolbox, as Scott said, being that human, to determine how we can rectify results that maybe we're not happy with, right? So and give the human maybe the final say for something as critical as the building blocks of our products, right? So a few techniques that we can use to just maybe flag to an individual. We can share back a confidence level, which maybe gives folks an idea of the confidence of the approach that we've taken. And maybe that's flagged to a user. And then we can use that information in some sort of exception reporting, pass it back, get that confirmation so that we can fundamentally continue to make decisions based off of that data. So I guess just concluding thoughts here in the session, just a couple cases that we see as really benefiting from the usage of AI. And the value of getting master data management right is huge. And it's something that we think is well situated for AI to help with really aligning those business data sets to those common hierarchies that we really need so we can speak the same language as one another effectively. And it's also well situated to enrich your attribution with product descriptions, unstructured documents, and other new types of data to understand new business dynamics and how we can use those new perspectives that we now have in order to actually identify more opportunity for us. And of course, humans are capable of assessing new source data, working out those mappings, and using and developing that enhanced attribution for our business dimensions, but doing so across hundreds or thousands of data files, bringing everything together for 10,000, 100,000 different products, it gets really, it builds up really quickly. And doing that, on a daily, weekly, monthly basis for new attribution that we want to define, for new data sets that we're bringing in, it just requires a scale that that really could be beyond what's possible for most organizations. So to conclude here, what we can do is we can apply AI and Gen AI to really automate work in the ways in which it wasn't previously possible, which is going to free up our team members to actually analyze that data and use it for the insights that we need it to. But all the benefit that AI can really bring to solving this problem really needs to be informed by the strong data engineering and governance principles that Sanjay referenced previously, while not overcomplicating that solution just for the sake of using AI, right? It's a really important balance to be struck, but one that will bring trust and buy-in while also driving that value for you and your organization.